Lepo pozdravljeni na 9. znanstvenem posvetu Raziskovalni izzivi živinoreji, tako imenovani Ločniškarjevi dnevi. Glede na to, da imamo danes 4 eminentne predavatelje iz tujine, smo se odločili za izvedbo v obliki webinarjev. In za začetek prosim prodekanjo, profesor dr. Tatjano Pirman, če lahko spregovori nekaj besed, potem pa bomo nadaljevali z prvim predavateljem. Prosim tudi vse, da če lahko izklopite mikrofone, čeprav sem nastavila tako, da načeloma ne bi smeli mikrofoni biti prižgani. Tekom predavanja seveda ste povabljeni, da napišete vprašanja v chat oziroma po končanih predavanjih lahko tudi vprašate predavatelje direktno preko mikrofonov. Tatjana, prosim.
Hvala lepa. Kot rečeno, smo se zbrali na 9. znanstvenem posvetu Raziskovalni izzivi v živinoreji, ki smo jih poimenovali po našem zaslužnem profesorju Francu Ločniškarju. In letošnja tema je tesno povezana z globalnim segrevanjem, ki smo mu priča v zadnjih letih. O vzrokih za globalno segrevanje poteka ogromno razprav, tako strokovnih kot tudi laičnih, in iz zgodovine vemo, da se pravzaprav segrevanje in ohlajanje našega planeta Zemlje dogaja ciklično, pa vendar je večina strokovnjakov mnenja, da trenutno segrevanje poteka prehitro in da to ni del naravnega cikla. Zdaj, veliko se pogovarjamo o segrevanju, najpomembnejši plin tega segrevanja ozračja je ogljikov dioksid. Tega v veliki meri pravzaprav povzročamo ljudje s spuščanjem v ozračje, pokurimo, še posebej pa tudi za vsakodnevno vožnjo z avtomobili z motorjem na notranje segrevanje. Pomemben toplogredni plin, ki pa je bolj povezan z živinorejo, je metan. Torej, tu nastopi živinoreja in različne bakterije, ki živijo v vampu prežvekovalcev. Prežvekovalci te bakterije izkoriščajo zato, da se lahko prehranjuje s celulozo, ki je za večino sesalcev neprebavljiva. Pri razgradnji pa nastajajo različni plini, med njimi tudi metan, ki ga pa prežvekovalci izločajo z izrigavanjem. Vendar pa metan iz krav ali prežvekovalcev predstavlja le majhen delež toplogrednih plinov, saj metan nastaja v veliki meri tudi iz naravnih virov in ocenjujejo, da je tega pravzaprav več kot oziroma približno 50%. Res je tudi, da je metan močnejši toplogredni plin od ogljikovega dioksida, a ga v atmosfero spuščamo precej manj in prispeva k toplogrednim plinom samo okrog 15%. Lahko bi se še pravzaprav igrala z različnimi številkami in na koncu ugotovila, da je delež, ki ga prispevajo krave z svojo prebavo k toplogrednim plinom, ki ga spuščajo v atmosfero, manjši kot 5%. In torej, če opustimo živinorejo, ne bomo veliko prispevali k zmanjševanju toplogrednih plinov, o tem, kar se pravzaprav zadnja nekaj mesecev kar precej pogovarjamo. Ima pa živinoreja ključno vlogo pri ohranjanju krajine, saj je na svetu praktično 50% površin, kjer je mogoča le paša, torej kjer ni mogoče pridelovanje poljščin, in krave oziroma prežvekovalci so pri tem ključni. Da ne bom šla predaleč, zagotovo lahko še kaj storimo, da zmanjšamo tudi izpuste metana v živinoreji in nekaj možnosti nam bodo predstavili naši današnji predavatelji. Torej še enkrat dobrodošli, prepričana sem, da bodo predavanja zanimiva. Hvala vsem predavateljem, ki so se odzvali vabilo in pripravili predstavitve, predvsem pa hvala dr. Marije Klopčič, ki je povabila te eminentne predavatelje in pravzaprav organizira ves ta dogodek. Zdaj pa še par besed v angleščini za goste iz tujine in pa za predavatelje, da ne bomo samo v slovenščini govorili. Welcome to the 9th Scientific Conference Research Challenges in Livestock Production, which are named by the Professor Franz Ločniškar. This year's theme is closely linked to the global warming that we have seen in recent years. This is a huge amount of debate about the causes of global warming, but both professional and laic. We know from history that warming and cooling of our planet is happening cycling. And yet most experts believe that current warming is going on too fast to be part of natural cycle. Methane produced by the ruminants are secreted into the atmosphere by and it is very linked to the global warming, but not as much as some people think. There is currently more we can do to reduce methane emissions in livestock farming as well. A few options will be presented to us today by those lectures. So welcome again. I'm sure the lectures will be very interesting, and thanks also to all the lecturers who responding to the invitation and preparing the presentation, and especially thanks to Dr. Marija Klapčič, who invited those lectures and organized this event. So welcome.
Hvala lepa, Tatjana, za pozdravne besede, za uvod. Pa bomo kar prišli k prvemu predavanju, in sicer profesor dr. Jean-Louis Peyraud iz Francoskega nacionalnega inštituta za kmetijstvo, prehrano in okolje iz Francije nam bo spregovoril o bistveni vlogi živinoreje v krožnem in trajnostnem prehranskem sistemu. Profesor dr. Jean-Louis Peyraud je posebni svetovalec znanstvenega direktorja za kmetijstvo pri Nacionalnem inštitutu za kmetijske raziskave v Parizu. Po doktoratu na Univerzi v Rensu 1983 se je ukvarjal predvsem z raziskavami na področju prehrane krav moznic, prireje mleka na paši in v povezavi prireje mleka in okolja. Mednarodno slavo si pridobil s svojim raziskovalnim in strokovnim delom na področju menedžmenta paše in upravljanja s travinjem. V času njegovega izjemno bogatega profesionalnega dela je imel več vabljenih prispevkov na mednarodnih kongresih. Poleg tega je kot vodja delovnih paketov sodeloval pri več evropskih projektih, kot so Grezmor, Rednex, koordinira tudi projekt Multisword v okviru FP7 programa, katerega cilj je izboljšati konkurenčnost in trajnost sistemov prireje preživkovalcev, ki temeljijo na travinju. Ta projekt je prejel priznanje zgodba o uspehu na evropski ravni in priznanje Zvezda Evrope strani francoskega ministrstva za raziskave leta 2014. Pri INRAE je ustanovil in bil vodja skupne raziskovalne enote za prirejo mleka med Raziskovalnim inštitutom INRAE in Agrokampusom. Nedavno je tudi koordiniral znanstveno nacionalno ekspertno oceno 22 strokovnjakov o pretoku dušika v sistemih živinoreje. Profesor dr. Jean-Louis Peyraud se ukvarja tudi z organizacijo raziskav in razvoja svetovalnimi službami, katerih cilj je razvijati in spodbujati bolj trajnostne sisteme reje mleka. Je vodja Združene tehnološke enote, raziskave in inženiring pri reji mleka med Raziskovalnim inštitutom INRAE in francoskim živinorejskim inštitutom French Livestock Institute, ki se ukvarjata s sistemi prireje mleka in ki usklajujeta proizvodno in okoljsko učinkovitost. Je tudi predsednik Združenja živinoreja jutri, ki združuje vse akterje, raziskovalne, svetovalne in pa industrijo, ki so vključeni v živinorejsko proizvodnjo v Franciji. Na evropski ravni je trenutno sopredsedujoči javno-zasebne platforme Animal Task Force, ki spodbuja trajnostni in konkurenčen živinorejski sektor s spodbujanjem razvoja znanja in inovacij v Evropi. Skratka, profesor dr. Jean-Louis Peyraud je v Evropi in v svetu eden najbolj eminentnih raziskovalcev na področju, ki sem ga omenila v njegovi predstavitvi. Professor Jean-Louis Peyraud, please, can you say some words in English about you? And then you can start with your presentation. And thank you very much for your time and for your willing to share your knowledge with us.
Okay, thank you, Maria. So, hello everyone. So I'm very pleased because I see that we have 90 participants, so the Congress will be a success, clearly. I will share my screen. Just a few words about me. I understand that Marina explained who I am. Indeed, I spent most of my time as a researcher to work on grassland management, milk production on grassland. But since 15 years now, I take some responsibility at INRAE level. I work at the scientific direction of agriculture, and I am in charge of all aspects dealing with the livestock production for research. And from this work, I am involved in Animal Task Force as president of Animal Task Force, and I am also involved in the SCAR group of sustainable animal production. So I have a broad vision about livestock in Europe, the driver for the future, the problem of livestock, but also some way to make progress. And I will try to stress on these different aspects during my talk. I will try to share the screen.
Yes, you can share.
Okay. Is it okay?
Yeah.
Okay. I will.
You can use slide show.
Okay. Like this, it's better?
Yeah.
Okay. So a few explanation about the essential role of livestock in circular and sustainable food system. My presentation will be in two main parts. The first will deal with the livestock impact, so the negative aspect of livestock, if you want, and the driver of change. And in the second part, I will explain how and why livestock could be a solution for more sustainable food system. So indeed, we are under the pressure of life cycle analysis, and many publications have always shown the negative impact of livestock and animal source food. Here it's one of the most important papers from Peyraud and Mizeck, which was published in Nature 4 years ago, showing the carbon footprint of beef compared to, and beef and other animal products compared to plant-based product. And you see that the best animal product, which is eggs, is 2 times more important in terms of emission than tofu. All this paper claim that livestock is negative for climate, for biodiversity, for resource use, and for quality of ecosystem. In addition, we have also other concern about livestock concerning the health of livestock and antibiotic use, animal welfare, livestock production system, and nutrition. But today I will focus on the black keywords. Probably, and I'm convinced that this vision is very simplistic, but reminds us that we need to find some way of improving the sustainability of livestock farming. And reducing livestock production appears to be an obvious solution. When you see this graph, you say, okay, I don't eat beef, so it will be better for the planet. Probably it's not so simple. Livestock and climate. Clearly, at world level, global vision show that livestock is very important in terms of greenhouse gas emission, more than 40% of total GHG emission. And in livestock, bovine meat and bovine dairy are the most important. Both together, they represent more than 50% of greenhouse gas emission. The food sector is also important in terms of anthropic emission compared to transport or other issue. And a quarter of our emission is linked to the food sector. So this clearly puts the pressure on food system and livestock within the food system. And at European level, we have a climate law, and I show here what is the expected reduction of emission from the different sectors at European level until 2050. And you see that the non-CO2 of agriculture, which is the green line here, should decline during the time course. Concerning the COP21, the conclusion that we need to reduce clearly all greenhouse gas. And for agriculture, the objective is to reduce methane by 50% and nitrous oxide by 20 to 30%. So it will be a huge pressure on livestock in the future. And residual, we claim that we cannot stop totally the emission of the livestock sectors, but at the time horizon of 2050, the emission of the sector must be compensated by carbon storage, at least It's the vision of the EU Commission at the moment. And concerning livestock, we can wonder why methane is so important. Because atmospheric methane concentration is increasing, as you can see here in the figure, because from year to year we have an increase. After we are happy at the beginning of the century we have a plateau, but still the beginning of the century it increased again. And methane contribute to half of the global warming we observe today, 0.5 degrees in relation to 1.1 degrees. Livestock and rice production are the most important emitters at agricultural level, and livestock much more than rice. But in the same time, methane is a short-lived greenhouse gas. It means that the half-life of methane is 10 years. So reducing methane emission will reduce the concentration in the atmosphere. And a rapid reduction of methane will have a significant effect on climate, I mean temperature this time. And during the COP27 in Glasgow, most of the countries signed the Global Methane Pledge, which is an agreement to reduce methane by 30% in 10 years between 2020 and 2030. Again, it's a new pressure on livestock, and this ambition will reduce climate change by 0.1 degrees. So to limit warming, it's clear that we need to stop CO2 and N2O emission start now, but we need to reduce methane, but only to reduce methane, not to stop methane emission. It's very important for the livestock sector because CO2 and N2O is much more impacting on long term than the methane. But on short term, we need to reduce methane just to avoid too high increase in temperature in 10 or 20 years. Okay, so Europe can show the way, but we need to keep in mind that Europe is a small player at global level. You see here the number of livestock in Europe, 100 million, compared to 1.3 billion at world level. So the size of the herd in Europe is small compared to the world herd. And in the same time, in Europe, we have the most efficient system, both in terms of meat and milk greenhouse gas emission, greenhouse gas emission for meat and milk production, compared to the other part of the world. You see, for example, that in Asia or in Africa, the carbon footprint of meat is 3 to 5 times more than we have in Europe or in North America. So small herd, very efficient herd. So we are a small player, but we have technology to pave the way for progress. A second aspect dealing with animal impact, livestock impact, is the resource use efficiency. It is claimed that livestock use 70% of agricultural land. It is clear, and Anne Motet from FAO produced this kind of data. It's clear, but within this 70%, half of the total is in the permanent grassland, which can only be used by herbivores or by forest. So this part of land is not in competition in terms of food production with other parts. We have 20% of land used by livestock, which are rotational grassland. It means that grassland which is used in rotation with wheat, barley, rapeseed, sunflower, and so on, so other grain production. So this part can be used for cropping, clearly, but this part also produce ecosystem services, and some scenarios developed at European level show that we need to maintain this grassland just to maintain ecosystem services, and so we need to maintain ruminants. And the last part, 14% of total agricultural area is crop system, which is used to feed livestock. And this is this part which is really in competition between feed for livestock and food for human. And 1/3 of total agricultural land at world level is directly for food production, cereal production for food production. So you see that, okay, livestock use a huge amount of agricultural land, but part of this use is very useful for other purpose. Nevertheless, concerning the productivity of land, it's much lower when we use land to produce pig, poultry, dairy, or bovine meat compared to grain. You see here a summary of different life cycle analyses produced at European level, showing that at maximum we can produce 300 kg of protein per hectare used to produce pig, poultry, and eggs, more or less the same level, slightly less for milk. But bovine meat is really an inefficient or far less efficient way of using land in terms of productivity, notably when we compare to grain, which we can produce up to 1 ton of protein per hectare from soya and wheat. For other sunflowers, we produce only 400 kg of protein per hectare. So there is a competition between feed and food concerning this data. Another aspect is the livestock and biodiversity. Is livestock positive or negative for biodiversity? In fact, it's very complicated issue. I'd like this kind of presentation proposed by FAO, showing that concerning biodiversity, we need to think about habitat change, we need to think about pollution, we need to think about climate change, and we need to think about the future of invasive species. And for both this issue, livestock can have some negative contribution in red or more positive contribution in blue. For example, concerning habitat change, we can destroy or occupy the habitat for livestock production, and typically is deforestation in Amazonia, you can see on this picture. But at the same time, livestock can create or restore or maintain habitats. For example, concerning landscape connectivity, this is a typical landscape of mixed farming system with crop and livestock together. You see that we have grassland, we have edge, so we have a very diverse system which can protect wild fauna. But in the other side, we have landscape fragmentation, and it is very negative. Concerning climate change, the negative effect is greenhouse gas emission, but we can have positive effect with soil carbon storage, as notably in wheatland, as I show in this photo, in this picture. Concerning pollution, effectively, if we consider it's a beach in Brittany with green algae, clearly it's very negative for biodiversity. But on the opposite, livestock can contribute to the circularity of nutrients, and I will show some example just after. And concerning invasive species, livestock can be used to control invasion, but it can also be unfortunately used to disseminate invasive species. So both positive and negative aspects. Be careful, again, Europe is a small player. Concerning deforestation, Europe imports 10% of the global embodied deforestation at world level. Soya used in Europe represent 6% of global deforestation, and 10% at European level is because we import soya, meat, palm oil, cocoa, rubbers, and timbers. So, okay, we import deforestation, but it is a small part at the world level. The last aspect, which is very important in some place in Europe, is local pollution. And indeed, 80% of nitrogen of agricultural origin is present in aquifer, and 90% of ammonia emission came from the agricultural sectors and indeed the livestock sector. You see here the map from the European project Nitro Europe, or the work we have done in France. It's more or less the same conclusion concerning nitrate and ammonia, and you see that when it is red and or purple, it's much more intensive emission, and you see that the European West Europe, Northwest Europe is a major issue for this pollution. Brittany in France, Netherlands, Denmark, Ireland to some extent, but also the Po Valley in Italy, both for nitrate and ammonia. So local pollution, there is an indisputable role of livestock. So we will move progressively to the second part of the presentation. Indeed, when you look at what I've done in agricultural sectors since the Second World War, we have developed a linear approach. For the crop system, we use more and more mineral fertilizer and pesticides. And for the livestock sectors, we develop specific crops to feed livestock, for example, maize silage. This leads to a huge improvement of efficiency. I put here one example, which is for the poultry sectors, which show that the consumption index to produce 1 kg of poultry, which declined from 2.2 to 1.7 kg of feed per kg of weight gain between the early 70s and now. We have exactly the same figure for pig, for dairy, and for beef. So improve efficiency. It's also clear for wheat, but in the same time, some negative aspect appears, notably in the crop sectors. When you see we have no yield gap. Until 90s, we have a huge increase in yield production, wheat production per hectares, but still the beginning of this century, we have a plateau. We have still more productive genetics in wheat, but we cannot achieve the genetic improvement on the field. We have also price volatility with the mineral fertilizer. This is the crisis we have today with the price of fertilizer, which is multiplied by 4 or 5 compared to 2 years ago. We have the same problem in 28 here, and now we have another crisis. So crisis for price volatility. And we have a lot of negative effects. I discussed about climate change for the livestock sector. I discussed about pollution. We see that the biodiversity in agricultural landscape is decreasing since the early 70s. Here it's an indicator developed by Worldwide Farming System. And the use of pesticides increased dramatically. You see that the production of crop increased by 50%. Yield per hectare increased by 50%. The amount of fertilizer increased and now is decreasing, but the use of pesticides is highly increasing. It means that linear approach with a specialized farming system, we produce crop or we produce livestock, is not sustainable on the long term. We destroy biodiversity, we have yield gap, we have local pollution, and we have climate change. So the question is, shall we reduce livestock and fade away livestock, or is livestock essential? And for me, the question is, shall we think about footprint or about the role of livestock in circularity? When you look at the footprint, here it's just an illustration taken on internet, so it's very common vision, and everybody can see this kind of thing, and you see, okay, again, the meat production is dramatic in terms of greenhouse gas or in terms of water utilization compared to crop systems. So please destroy livestock and the world will be better. And we have this kind of sentences in many papers, and notably in papers for normal public, large public. Avoiding meat and dairy is the single biggest way to reduce our impact on Earth. It's not to reduce the use of car, it's just to reduce meat and dairy consumption. But this vision just forget that agriculture is circular. We have crops, and like livestock is the link between the crop and the soil, thanks to manure. And the soil is the base of cropping system. And livestock can maintain the soil quality in a good state. So this vision, life cycle analysis, is a very narrow vision of livestock role. And livestock is very important because it can recycle into the food chain non-edible biomass. It can provide nature-based organic fertilizer. It can enhance crop diversification, and it can provide ecosystem services. I will show you some example of this specific issue. And so classical life cycle analysis is not the whole story about livestock to direct a food transition. We need to tell another story for livestock. And this is the second part of my presentation. Livestock is clearly part of the solution for circular agriculture. First aspect is greenhouse gas and climate smart food production. When we think about the role of livestock for emission, it's huge, so we can reduce it. We can work at animal and herd level. We can think about manipulation of manure. We can think about land use, or we can think about the feed production and the ration of the animals. Thinking about animals and herds, it is just a slide showing the role of circularity in this aspect. If we work on animal, we can select low-emitting animal. We can advance age at first calving. We can reduce culling rate. For example, increasing the number of lactation per cow from 2 to 3 or 3 to 4 will reduce carbon footprint of milk by 10%. We can reduce slaughter age in case of meat production, and we can produce more meat from the dairy herd because the carbon footprint of the calf is very low at this time because the mother produces milk and a calf. In a circular system, the mother only produces one calf a year. And this action at the animal level are very interesting because they permit to reduce a little bit the number of livestock for the same level of production of milk and meat. So we lower emission also of ammonia, of nitrate, of N2O, nitrous oxide. We will use less land because we will have less livestock. We will reduce the use of fossil energy, and it will be more easy to increase autonomy in feed production. Concerning the feed production and the link to the animal, we can use feed additive. We saw in the last EIP Congress in Portugal last year that free NOP is a very efficient feed additive. We can also think about algae or omega-3. We can use more legumes. Using more legumes, avoid to use a mineral fertilizer. So it's we can spare emission of energy and of nitrous oxide. The higher will be the quality of forage, the lower will be supplementation. So it will be also a way to reduce emission. Grazing is better than stall feeding. And for monogastric production, precision feeding can be a good tool to reduce emission. Concerning the manure, you will see in another slide, but using more organic fertilizer instead of mineral fertilizer will help to reduce N2O emission. And we can also produce biogas to reduce the carbon footprint of meat and dairy production. Concerning land use, we need to develop land management which help us to store carbon in the soil. It means grassland, agroforestry, and development of edge. So you see that using circularity, we can have a different way to dramatically reduce the emission of the agricultural sector. Probably, we can expect 50% reduction of intensity of emission for the same production. Just an example coming from Netherlands, showing how they use this, they try to use this circularity to reduce or to expect to reduce greenhouse gas emission. This is the vision of the Netherlands Dutch agriculture. In gray is manure, in orange is feed, and feed including methane emission, and in blue is crop sector. You see that there is a decline of total emission in Dutch agriculture. This is the expected reduction is 2050. Using linear approach of agriculture, as it is the case today, using circularity and so synergy between livestock, crop, and soil, you see that we have a further decrease in emission. So clearly, circularity is a powerful tool to reduce the carbon footprint of the food system, and livestock is part of the solution. Soil carbon storage. Just two examples. Concerning grassland, you see that the soil carbon stock under grassland is at the same level as under forest, 80 tons of carbon per hectare, far higher than the carbon stock under cropping system. But if we have well-managed grassland, we can increase the carbon stock on the soil by 250 kg per hectare and per year. For it's almost the same level as in forests, keeping in mind that in the same time, the soil under specialized cropping system are still losing carbon, 100 kg per hectare and per year. But if we introduce temporary grassland in this crop rotation, we will have a dramatic effect on dynamic of carbon with a huge storage of carbon during the first years, 400 kg per hectare and per year. And we can also use intercrops. I will come back on intercrop just after. And here, so the role of grassland to manage carbon in the soil and to increase soil carbon storage. We can also think about organic fertilizer and solid manure. This is here the result of a long-term experiment managed in France, showing that if we spread 1 year every 2 years some solid manure on the soil in a cropping system, you see that we have an increase in soil carbon content compared to the same rotation, but using only mineral fertilizer with no organic fertilizer. So we see here an example of what could be the role of livestock in a more sustainable agricultural food chain, because we can store carbon in the soil thanks to livestock. LCA claim that we need to reduce livestock and it will be better, but we need to take care of this way of thinking, because if we reduce livestock in Europe, probably we will have a growing imports of meat and milk, because the consumption doesn't decrease so rapidly. We have a risk of increased GHG emission by transferring the production of livestock from Europe, which is very efficient. Remember the graph I showed you a few slides ago, to less efficient region. If we produce more in South Asia and less in Europe, it will be clearly negative in terms of greenhouse gas emission at a global level. Reducing livestock and ruminant will lead to a reduction of grassland. You see here the result. I understand that Maria speak about my role in multi-sward during the presentation. One of the results of multi-sward is this way. You see that we have a decline of ruminant in Europe since the early 70s, and we have a decline in the land, in the proportion of the area of grassland in total. So it means that we will have reducing dramatically livestock. We will lead to a conversion of grassland to crop land in plain region, or to fallow land or forest in mountain region. But in all cases, this will lead to a loss of biodiversity and a loss of soil carbon emission. Even in the case of forest, during the first years, we destroy grassland, and in the first year, the forest doesn't exist. And the last but not least, if we reduce dramatically livestock in Europe, what will be the future of marginal lands? What with different risks of encroachment, risk of fire. We have more and more farm in forests in Europe due to climate change. So we have no fire in grassland, and the biomass can ferment and can produce methane too. And I don't speak about the role of of livestock in rural vitality in marginal zone. The second point is circularity in feed efficiency. We need to keep in mind that livestock recycle non-edible biomass as human food. You see here the result of a paper we produced with Animal during EIP Congress 2 years ago, showing that livestock produce more edible, or can produce more edible protein of animal origin per kg of edible protein of plant origin, which is used as animal feed. Okay, animal use a lot of protein, but 50 to 95% of the protein used by livestock are non-edible as human food, and so they are not in competition with our food. Ruminant is clearly efficient. You see that at global level, we can produce 1.6 kg of protein in meat and milk per kg of plant protein, which is edible as food and used by livestock. It's less efficient for ruminants. And in Europe, sorry? It's for me? Here it just a result in Europe, in France, showing that in grassland-based system, dairy cow is very efficient and produce up to 2.5 kg of protein in their milk and meat per kg of protein of plant. Even pig production can be very efficient if we use feed byproduct. So you see that this competition between feed and food should be carefully studied, and livestock is not so much in competition with food production. Even also because livestock are able to produce food from marginal land. And just here some example, and you see picture of meat production under forest, under very dry zone in Africa or in Mongolia. So I will keep this slide. The third point is circularity for crop diversification with different trade-off and positive trade-off. Up to now, we feed livestock with cereals, byproducts, and dedicated feed crop, maize, for example, or grassland. But in the future, we can imagine that we can also feed livestock using crop residue, using intercrops, using, which is, I think, much more important, mixed crop or dual purpose crop. We can use 1 hectare of land to produce in the same time feed and food. This is classically the role of rapeseed. For example, we produce oils and we produce cake. This is the example on this slide of a new culture which mixes wheat and peas. Wheat for human and peas for livestock. And it is very efficient because we use less mineral fertilizer. We can also in the future use insect and fungi. And this circularity in the feed system will help us to produce more local protein, to reduce the use of mineral fertilizer, because legumes produce the equivalent of 100 to 300 kg of nitrogen per hectare instead of mineral fertilizer. We will reduce nitrous oxide emission. We will favor carbon sequestration, increase agrobiodiversity because diversity of plant which is sown and grown, less less use on land for feed crop because we produce in the same land different crops, more resilience to climate change because more diverse feed, and less pesticide use. This is here the result of one big experiment in France involving 3,000 farms, showing that the number of treatments per hectare is lower in mixed farming system compared to specialized crop farming system, 2.3 compared to 3.7. So again, this is a role of livestock to reduce pesticide use. And livestock is really essential to value protein-rich crop, and we can produce huge amount of local protein to feed livestock instead of soy import. This is here just a simulation I produced for France, showing that our livestock today can use 0.7 to 1 million tons of local protein, peas, for example, instead of 30% of soy import. It will use 1 to 1.5 million hectares compared to 9 million hectares of cereal. And you see that what happened from an historical point of view. In 92, we have a CAP reform, and this CAP reform gives subsidies to cereal and suppress subsidies to peas. And you see that the production of peas decreased dramatically, and today we don't produce peas anymore. And at the same time, the composition, the volume of peas used in animal feed, notably the pig in blue, decrease. It's not because pig cannot use peas, it's just because we have no peas on the market. And even forage legume can be used much more intensively than it is the case today. Here again, it's a simulation in the French case when I replace 30% of maize silage by lucerne for 2 million cows, and you see that we can save 200,000 tons of soy protein. It means 35% of soy protein imported in France. And even this lucerne or red clover can be used by biorefinery to feed pigs. There is an interesting work in Denmark, notably Jorgensen and colleagues, showing that biorefinery of green lucerne can produce green protein for pigs, pulps for ruminant, and some residue which can be fermented to produce biogas. Fourth point, circularity in manure-based fertilization, how we can turn a problem into an opportunity. Indeed, at European level, we have more or less the same amount of nitrogen in mineral fertilizer or in manure. But using manure will reduce, using quite interestingly, manure will reduce N2O emission. You see here, because at livestock sector, using LC analysis, we put most of the greenhouse gas emission to the meat and the dairy and the milk. So it means that co-products have more or less no impact. And it is a case of manure compared to mineral fertilizer with the Haber-Bosch method, who require a lot of fossil energy and produce a lot of nitrous oxide. And even during spreading, we produce more nitrous oxide with mineral fertilizer with manure, according to the light IPCC reports. The problem of manure nitrogen is we have a huge risk of ammonia emission. So we need to reduce ammonia emission. But basically, better use of manure fertilizer will improve greenhouse gas emission of the food sectors. We can expect an 80% reduction or 90% reduction of ammonia losses between animal and the provision of N to the soil, both using grazing because it's a direct recycling, or we can also avoid urine and feces mixing in building. I think about pig production at this time, but we can also reduce emission by slurry tank cover and rapid burying of manure. All these points are well detailed in a number of scientific papers. So the margin of progress are very high. We just need some change in practice and investment. But like manure can also be used to produce new products and to develop a new value add and new value chain. Using cascading approach, from manure, we can extract ingredient, we can extract nitrogen and phosphorus, we can extract energy and water. We can produce marketable fertilizer or compost, and this marketable fertilizer and compost can be exported for very intensive livestock farming zone to other area where we have not enough livestock. In a specialized cropping zone, for example. And we can use manure for insect production in circular economy. So you see that thinking circularity provides a huge way of improvement of our food system thanks to livestock. Livestock is also very important for agrobiodiversity because we have higher diversity of species cultivated in rotation with different flowering dates. So it's good for pollinizator. And we have a diversification of soil use, which went into landscape maintenance of open habitat. And you see that it's this landscape mixing cropping system and grassland and hedge. We have much more habitats for wild fauna compared to this open field system which is a very flat with no habitat for wild fauna and wild flora. In France, one livestock unit is associated with 90 meters of hedge. So without livestock, we will have no hedge, so a decrease in number of habitats. Grassland is a hotspot of biodiversity. Indeed, 50% of endemic plant species in Europe depend on the biotope of permanent grassland. Permanent grassland, the soil of permanent grassland is very rich in biodiversity. Here we have the number of invertebrates, sorry, it's in French, under grassland, under cropping system with no strip cropping and strip cropping. And here is a proportion of flower which is fertilized in grassland and 900 meters far from the permanent grassland. You see that we have the far we are from the grassland, the lower is the number of flowers which are fertilized. The last point is circularity for long-term sustainability, and again, the role of livestock in soil. Soil organic matter, I show you the picture just before. Soil erosion, we have much less erosion under grassland compared to under cropping system. This is the mean data in ton of organic matter per hectare and per year from Eurostat. And here it's new results showing that under grassland, the biological activity of the soil is much higher. Here is the activity in terms of protease for annual crop, temporary grassland for 3 years, 6 years, and permanent grassland. You see that we have an increase in soil activity. To think the future, we need to think integrated, inclusive, interdisciplinary research. We have 4 sustainability domains aligned with SDG. We discussed today about climate, biodiversity, and natural resource, but we need to think about animal health and welfare, food and nutrition security, and livelihood and economic growth. As a researcher, I claim that we need research at animal level. We need to think about what is a circular animal, which is more efficient, more robust, more resilient. It means research at microbiome, genome, epigenome, function, cognition, if we think about animal welfare. We need to develop multi-performing system. So how we can manage at the farm level, the animal, the feed, the building, the manure, the role of numerics and robotics and farmers which manage the system. And at the global level, we need to think about sustainable and resilient food system and to think about the connection between livestock system, plant system at the landscape level, market and price, consumption pattern, and the role of the food chain and public policy actors. So you see that we have a different scale, and we need to manage all the scale together. And to conclude, I have convinced you that connected circularity in the integrated agro-food system is clearly the option for a resource-sufficient and emission-free food production with the planet, which maintains the planetary boundaries in agreement with the Green Deal ambition and the related EU strategy. Livestock is needed to close the cycle in a regenerative use of resources. We need to reduce resource use, but we need also to regenerate resource, and livestock is very important for that. The livestock production system could and should be transformed to optimize their role in the future. This also requires circular breeds and precision farming. So clearly, the future of livestock will be different as livestock is today, but we need to maintain livestock. This transition for the livestock system requires inclusive and interdisciplinary approach I have shown in the previous slide. And we need to keep in mind that some emissions are clearly inevitable because there is no healthy ecosystem without livestock, and livestock, notably ruminants, emit some ammonia. Thank you for your attention, and keep in mind that livestock farming systems are much more than only food production, and this is not taken into account by the current life cycle analysis. Thanks again.
Thank you very much, Professor Jean-Louis Peyraud. Very interesting presentation, and I'm sure that our participants have some questions for you. I saw one remark or question. Yeah, Mrs. Vesna Habazin wrote that methane has big green gas effect, but in atmosphere is not stable. And carbon dioxide, so it's not such big problem in comparison to carbon dioxide as it is mentioned.
Yes, I partly agree, and I try to explain this in the first slide. Indeed, it's quite a complicated issue. On a short-term basis, methane is very important because its greenhouse gas effect is 80 times more than CO2 during the first 10 years, if you want. So we need to reduce methane for this region. The problem is in Europe, because we have a reduction in ruminants globally. It means that methane doesn't become a problem because we reduce emission of methane. But at global level, it's not the case because the number of ruminants is dramatically increasing in Asia and in Africa. And I think that as a European researcher, it is of our responsibility to help this country to develop their meat and milk production using a lower amount of livestock, but better using their livestock, notably in terms of management of health and productivity. It's very, for example, in Africa, we have a lot of cows which produce less than 1,000 liters of milk or lactation. It's quite easy to increase the production to up to 2,000 liters. So it's still very low, but it's 2 times more per cow. So it will help them to reduce the number of animals. So I think this is really a big challenge. In Europe, we need to clearly not to increase the livestock number. We need to reduce ammonia intensity of methane emission per cow. And to reduce a little bit the number of cows. But to reduce the number of cows, we see that we have some limits. I explained that it's difficult because we will have some quite negative effect in landscape management, in losing soil carbon by destroying grassland. But we can improve and reduce intensity of emission per unit of milk and meat products by reducing a little bit the livestock number, but a better use of livestock. we can produce the same amount of milk and meat with slightly less livestock in Europe, rethinking the balance between suckler cows and dairy cows, notably in some countries, and in reducing the number of replacement animals. If we increase the number of lactation per cows, we will reduce the number of heifers we need, so we can produce meat from these heifers instead of using suckling cows. And just using suckling cows in area, in region where we can do nothing else than suckling. For example, in France, in the French Massif Central zone, in humid mountain area, for example.
Thank you. Mrs. Anna Peter asked, do you think that it would be sensible to make or build a new way to calculate LCE, taking in all of the social, economic, and other factors that the livestock has, like using grassland that otherwise couldn't be utilized? If yes, how do you think this could be calculated?
Yes, for sure. Yes, for sure. I'm convinced on this. I have not enough time to, but another part of my presentation would have been to be how we can improve LCA. For example, okay, LCA, it just imagine that we use livestock to produce food. But indeed, we use livestock to produce biodiversity landscape. We also use livestock to produce byproducts. It's just crazy to think that the carbon footprint of your steak is very high, but the carbon footprint of meat you give to your dog or your cat is no carbon. Just because we have an allocation during the LCA calculation. So we produce byproduct, we produce something else but food, and we produce food. And LCA only consider food. So we need to change. The question is, have we some indicators to evaluate the positive effect of livestock? And it is quite difficult. We have some indicators in terms of biodiversity, but we have several European projects are still working on this topic now, notably the Pathway Progress project. Another possibility is very simple. I see a paper this week. We can also make an allocation of greenhouse gas of the animals in terms of economy of the price of meat, but also the price of ecosystem services, which are now rewarded by the CAP. So we can use this kind of growth indicators in the first time, and it will reduce the carbon footprint of meat. I'm convinced that we have a wrong view of the carbon footprint, the real carbon footprint of meat and meat.
Mm-hmm. She also asked, so it should be extended?
Yes, it is. Yes, it is. Yes. It is. It's the same way of thinking. We need to extend, and it's exactly when I say that be careful of reducing too much the livestock number in Europe. Okay, today the life cycle analysis say we need to cut livestock to reduce greenhouse gas, but there is no extension of the thinking about and what else after. If we reduce livestock, what will be the future? We can produce forest, but the forest can burn. So in final, the carbon footprint, the global emission will not decrease so much. So, and it is not taken into account. So I agree 100% about it should be extended.
Thank you. My question is also, I have impression that all these environmental issues are pressed on the European farmers and researchers and advisory. But if you look on the global level, you can see that the number of animals increase in Brazil, in India, in China, Russia. On all other regions, they increase, but on another side, Europe go down with the number of animals, even that we are more efficient than in other regions.
Yeah. Yes, please convince the European Parliament of this. Yes, you're right. I try to explain in one slide. Europe is a small player, and the role of Europe is decreasing.
Yeah.
But in other countries, we have a huge increase of livestock farming. But to be honest, the problem of climate change is not linked to livestock. It's first linked to fossil energy, carbon, petrol, and so on. So we need to develop sustainable livestock farming system using far less fossil energy, I think. So for ruminant grassland is a good way of thinking.
How can we convince European consumers to be more friendly to livestock farming?
I have no final answer on this. We need to explain what is livestock and to provide arguments. As today I present argument for scientists, but we need to write this kind of argument is in a very easy way of thinking for consumer, to help consumer to understand all the challenge behind livestock. Okay, and we need to claim that, okay, today some of our livestock farming have huge problem, especially in intensive area with local pollution, with nitrate, ammonia. It's clearly a problem. It's a problem of animal welfare also in some system, but we can improve the system to solve this negative aspect, keeping in mind that livestock has so much positive effect. So the problem is to explain this to the public, general public, but also for the actors and the stakeholders of the livestock system, that we need to make big change in our system. And I don't discuss today, but I think that animal welfare will be is really a crucial issue now for the society.
Thank you. I would like to ask participants if some other people have some questions, please. Now you have possibility to ask or write in the chat. I see a look on the participant if somebody would like to ask, but I don't see. I have one more question, a little more delicate. I have impression that in Europe we have war between livestock farmers and vegans. I don't know how it's in France, but in Slovenia currently we have a big problem, and that I think also in other regions in Europe.
No, I'm not sure we have problems. I think that the vegans are very active in social media. There are very few numbers, but very active. And I'm convinced that the problem is that now we have some politicians who are vegan in our parliament in France, at European Parliament. So they have a voice. And clearly, we need to explain that a world or Europe without livestock is just not sustainable. It's not sustainable from nutritional point of view. It's not sustainable for environmental point of view. It's not sustainable for efficiency point of view. If we use a vegan diet, we need more area, more land to produce the diet compared to a diet with a moderate quantity of milk, meat, and eggs. Because in a vegan world, we cannot use marginal area to produce food. We cannot use food byproduct to produce food. So we have a lot of waste, indeed. So we need to find a balance between this vision, which is just incredible and just impossible, and what we do today, where probably we use too much cereals, for example, to feed livestock. Okay, we can discuss on this point. But vegan is just crazy. So. Even in their mind and their way of thinking.
We have two more questions. Tanya Gorishek asks, what would you suggest to policymakers? What are the most effective measures to sustain livestock and to return on the sustainable track? How to change agriculture policy? And thank you for a very good presentation.
Thank you. I have no final response to this question. Again, this kind of I think that the kind of presentation I'll show you should be present to the policymakers. I know now that some policymakers clearly understand this, notably at DG Agri, notably. To some extent at DG Climate also. It's more difficult with policymakers in DG Env. They are thinking about, okay, a vegan world is not so bad, I think, for some of them, not all. So I think we need to develop scientific arguments and to explain this scientific argument. The second point is, okay, we discussed just before, is we need to improve our life cycle analysis, because today life cycle analysis just point the negative aspect and never point the positive aspect. So we need to and it will be crucial because we probably have in the future an environmental labeling on the food. And again, the animal source food will be with a very bad evaluation if we conserve a life cycle analysis.
Do we have some tool to do this?
But it's just to improve our life cycle analysis. As I explained, we have some a project as Pathway is working on this. But it's really, I think, that we need to develop research in all European countries about a new LCA analysis, taking account of more performances, more different performances, and as said in the previous question, extended life cycle analysis. Mm-hmm. It's clearly a big challenge, and it became the case because now policymakers are realizing that, for example, organic farming, the product coming from organic farms, are a very bad environmental footprint using LCA, because the productivity is declining, and because we consider only food production, not only food production, but the short-term effect on environment. There is nothing about soil fertility in LCA analysis. So if we decrease the fertility of the soils, typically in cropping area, we decrease fertility of the soil, but we produce protein in a better way than with livestock. So cropping system is better by livestock, but we don't think about soil fertility, claiming this. So we clearly need to have a huge work on life cycle analysis.
Thank you. Mrs. Anna Petek has one more question referred to the previous question. Maybe put a map of what distances their steak traveled, full used, emissions made, for example, if it traveled from a farmer in a neighbor farm or from Argentina to Slovenia. I think this would be a great marketing idea.
Again, basically, I agree totally. But it is not what is shown by life cycle analysis. You imagine that today, life cycle analysis show that importing lamb from New Zealand in Europe lead to a lower carbon footprint than producing lamb in Europe. Essentially because lamb production is efficient in New Zealand, and the travel by boat has a very low emission. But there is something wrong in this way of thinking, and it is not possible to demonstrate it is wrong using the current life cycle analysis. Again, we need to make progress in life cycle analysis. For example, just an example. One part of sustainability is the number of jobs we have. How many jobs is produced in Europe with import lamb compared to how many jobs is produced per kg of lamb produced in Europe? just the number of lump of job per kg of product in a labeling process will change the vision of livestock.
Yeah, I agree completely. Thank you very much, Professor John Luis. It was really nice to have you today, and thanks a lot for your time and for your input.
Okay.
And you are warmly welcome in Slovenia.
Okay. Okay.
Thanks a lot.
I will have more time to travel now, so I will go.
Please visit us.
Okay. Okay.
Thanks. Thank you.
Thanks.
We will continue with next speaker, Abele Kuipers. Abele came from Wageningen University Research Center, from Wageningen Livestock Research Group, and njegova prezentacija danes bo vezana na družbene razprave in uporabne raziskave o kmetovanju, ki skrbi za podnebje na Nizozemskem in v drugih regijah. Večina vas dr. Abele Kuipersa pozna. Dr. Abele Kuipers je študiral živinorejo in ekonomiko kmetijstva na Univerzi Wageningen na Nizozemskem in opravil doktorski študij na Univerzi Wisconsin v Madisonu v Združenih državah Amerike. Ameriško združenje za mlekarstvo ga je takrat tudi nagradilo za najboljšega mladega raziskovalca. Abele je v svoji bogati karieri upravljal tudi delo sekretarja oddelka za prirejo mleka v okviru nizozemske organizacije kmetov. 12 let je bil direktor eksperimentalnih raziskovalnih centrov za govedorejo, ovčerejo in konjerejo na Nizozemskem. Trenutno je direktor fundacije strokovnega centra za upravljanje kmetij in prenos znanja v okviru Univerze in raziskovalnega centra Wageningen. Njegova strokovna področja pa so upravljanje kmetij in razširjanje znanja. Aktivno podpira razvoj različnih orodij in inovacij na področju govedoreje. Moramo omeniti na tem mestu razvoj molznega robota in zadnje čase je vključen tudi v razvoj kravjega WC-ja. Bil je vodja in je še vedno aktivno vključen v več mednarodnih projektov, kot so twinning projekti med evropskimi državami, Erasmus Plus projektov, Eranet Suzan, FP6, FP7 in Horizon. 8 let je bil tudi predsednik komisije za govedorejo pri Evropskem združenju za živinorejo in je podpredsednik mednarodnega združenja za management na kmetijah. Abele je tudi zelo pomembno prispeval v razvoj slovenske govedoreje, kajti z njim aktivno sodelujemo že več kot 20 let in njegov prvi obisk je bil na Kmetijsko-gozdarskem zavodu v Ptuju v okviru sodelovanja z pokojnim magistrom Vladimirjem Tumpejem. Tako da, Abele, prosim, če lahko, Abele?
Maria, are you ready?
Yes. I kindly ask you if you can introduce in English a little bit. I try to explain some words about you and cooperation with Slovenia, but I would like that you explain something more in English language, and then you can start with presentation.
Well, Maria, you had a long story, it seems, about me. I was not able to check it. It may be partly, I hope it was true. Anyway, I'm from Nizozemska, for the Slovenians. And I'm a farmer's son, a dairy farmer's son. And most of my work was always in the dairy sector. Although I think we should talk a little bit wider than that. Dr. Peyraud just talked about environmental issues from the systems approach. And I think the system, that is the correct approach. So that is the way to handle these things. Nevertheless, I will do it a bit differently because I will just talk more about what are the goals we have to deal with as researcher and how we try to solve it. And the truth is that we don't have 20 years to solve it. It's more, it looks as if it needs to be done in the next years. So I really go to the field and just tell you a bit about how we, from an intensive living environment, deal with environmental issues. Dr. Peyraud already told it's not only the Netherlands that is in such an intensive situation, it's several areas in Western Europe are about the same. And in Italy, you have, of course, the Po area. And to be honestly, it may be that the valleys in Slovenia are not so much different than as we are farming. Anyway, we have a small country, not much bigger than Slovenia, but quite some animals and almost 18 million people in the meantime. And from that perspective, I talk a little bit about environmental issues. The next one, please, Maria. Maria, if you can turn on. Maria?
Yes, I turn. I see a picture with cow, but I don't know if you see.
No.
Okay.
I hope others, but I not. Yeah.
Now? Now?
Yeah. This is just how we live, a lot of water, small country. And we are in a struggle of finding the direction. I think that's true. Next one, please. A little bit experience, what I have as in my working career, and that shows a little bit the complexity. Before I was really active, you see on the top, I think almost all the focus was after the Second World War on production. And correctly so, we needed more product. In our part of the world, then animal welfare came. And the truth is, animal welfare in the 70s till today is the main topic. Surely in the environment I live in, animal welfare is the big topic. Then in the 80s, when I came in as a young fellow, we founded research farms to deal with nitrate leaching. That was a question from the politics. We found too much phosphorus and nitrogen in the groundwater, actually in the water, in the rivers and the streams. We made a huge effect when we started working on it. And in the 2000s, the quality improved and things were pretty much better. Till a few years ago, and suddenly the quality is not improving anymore. So it's again a priority. I never understood very well till recently why the quality did not improve anymore. But experts tell me it has to do with climate change. Our climate is changing and we have, and you may have it, much heavier rains and more dry periods. And that is not easy to handle nitrogen on the grassland and on the crops when you have that kind of climate. So we have more leakage again, and we need to give emphasis to that. Then in the 1990s, we had the emissions. I started working on that as a very young researcher, but many more. It was a big issue and we called it acid rain. The trees were hurt by ammonia, nitrogen emissions, not ammonia, just nitrogen. And we made big progress. I will show you later what progress we made in agriculture, especially in animal agriculture, but also the car industry, the autos. they became much more clean, and that was a huge improvement, and the problem faded away. Many years we didn't hear about it till 3 years ago. It came back in our country, nitrogen emissions. And I come back to that because we call it these days in our area a nitrogen crisis. And to be honest, it's each day in the newspapers and television. And then the big topic, greenhouse gas emissions, you all know recently we have to deal with it. And biodiversity, more and more emphasis, more difficult to deal with. Anyway, the next one, please, Maria. I will talk mostly about the emissions, but first animal welfare. That is not something I will discuss so much, but it is the main driver of all discussions about societal discussions about animal husbandry. I just give you two impressions. This impression is close to where I live. It's in the lowlands of the Netherlands. We have there a kind of a nature area. Actually, it's reclaimed from the sea. It's new land, and we did not cultivate it. Now it's a nature area. I'm skating there, as you see, in the winter time. But when it starts freezing, we find sometimes dead animals. I was skating and I made this picture. And the result is, and that may be in other countries not much different, then the people from Amsterdam, the city and so, come to this area and they protest because they don't want to see dead animals. That's the atmosphere and that's how we live. Nothing wrong, good discussion, sometimes more than discussion, but anyway. Next one, that's the discussion. Very recently, 1-2 years, nothing new for you, but we have the wolf in our country. And you cannot believe how we discuss about it. We just don't know how to handle it. Majority of people love it, and the people in the countryside don't know how to handle it. The truth is that our sheep farmers in the east of the countries put now the sheep in the nighttime inside. So our sheep farmers who can do it bring the sheep inside. And we have only 1 or 2 wolves in such an area. So now the government announced a public discussion about the wolf, how to deal with it. I think it's very good. So there will be public meetings in all areas in our country. How can we on earth live with the wolf? Very interesting, nothing wrong, but it is part of life. Next one, Maria. How is this is about the dairy sector, living with the rules the society in Europe is giving us. And they are very active. This is a certification scheme of our dairy companies. Just a little impression. On the left is what was done. Implement climate neutral plan on the farm, less antibiotic use, grazing is a big issue, more grazing. It's advocated by all parties. We need more biodiversity. We had rules for less greenhouse gases, 20%, that is recently changed. But anyway, more cows grazing, more long living cows. We want 6 months more. And we want social responsible soya to feed. On the right-hand side are new teams from which have to be filled in now. We need to look at a new climate agreement, and then new rules will come for the farmers for delivering milk. The sector needs to be, we want it to be land-based, so animals need to be tied to the land. That's different from pigs and poultry. And we want more safety on the yard. And that has also to do with emissions. Because the collection of manure in closed storages and so, we notice that it has also dangerous sides of some poisonous explosions and things like that. And that happens. We have accidents on the farms. So this is a bit what a dairy company can ask, force actually. It are strict rules the farmers to do. And each year, researchers or research organization checks the data if there is really improvement. So the dairy company has asked the research organization to check if there is really improvement. So it must be objectively checked. And that's a big thing actually. A report goes into the country with the results of that year. Next one, please, Maria. I go back to the emissions because I must admit, we talk about the nitrogen crisis in our country. And I don't know if you can see it, but it is each day in the paper, and this morning it was again on the front page. And you can't see it, it's turned around, is that right?
No.
Can you read that?
Yes.
Nitrogen, that's the front page of our main paper. It's really almost each day, television, how we deal with nitrogen in agriculture. And I want to continue a little bit with nitrogen and methane, because as researchers, we are asked to solve it together with, of course, the companies and the farmers themselves. What is the basis for nitrogen? The nitrogen discussion we have. But that's the same in all Europe, actually. But somehow we may more discuss it now because of intensity. The base for the nitrogen discussion now are the Natura 2000 areas. We are in a lovely country, but we don't have many nature, to be honestly. If I have a few trees, we already call it nature. And but we have one nature area in the center of the country, and it's pretty nice. But in 2000, we were so enthusiastic that we offered 162 nature areas to the EU. We said we have 162 nature areas, sometimes very, very small, sometimes even within a city. And now, and we promised, you promised it too in other EU countries, to keep those nature areas in the same status or even improve them, but at least they should not deteriorate. And now the impression is from experts in nature that our nature is deteriorating. Some rare plants, some very specific plants do not like nitrogen. So we have a problem. Nitrogen is coming from the air, and you will see from many places, but anyway. And that resulted in a guideline. No, it's more a regulation that nationally we decided that the nitrogen deposition on that kind of land, on land which we consider as very beautiful for little nature areas, it should not be more than 0.7 gram per hectare per year. 0.7 gram per hectare per year, that's the maximum. That can fall down. There is some discussion about it because, our neighbors in Germany, it's not 0.7 but 100 grams. So that is a little bit difficult. A farmer on our side of the border has the rule 0.7, and on the other side of the border it is 100 grams. But nevertheless, each country has to decide about that in a good way to keep nature in a good situation. And of course, we like to keep nature. I think each of us, nature areas. We have a model in our country that is used to calculate the deposition. Rules are, that is the basic scientific. We believe that in this area, and that will be not much different in adjacent areas, like in Belgium, we know it's exactly the same parts of Denmark. We believe that 42–45% of the net nitrogen in the air comes from animal manure. 12% from traffic, 9% from industry, and 32% from somewhere, perhaps even a little bit from Slovenia. Can you believe it? And 3% is estimated to come from the sea. And we have a lot of sea around us. Important is to know that nitrogen is not only ammonia. On the red line you read, it is ammonia plus nitrogen oxide. And nitrogen oxide is coming from traffic, industry, and wherever. Next one, please, Maria. This is the whole issue we have to deal with. But it is only recently we realized it so well, and it was in 2019. Actually, also as researchers, we were not so concerned about this all because we thought, yeah, you don't feel that nitrogen in the air, we don't see it, and only you can smell it sometimes a bit in barns, but not on the land. So perhaps very close to roads, you can smell it sometimes a bit, have all the traffic, but we did not realize it so much. But the world is changing, probably also a bit in your countries. You know that I lived in America for a while, and the tendency there is to go often to the courthouse to ask and to protest. You go with a case to the courthouse. And we see that in our country also increasing. More and more individual people or little groups of people or NGOs go to the courthouse. And they want the courthouse to check if regulations are executed exactly as the letter is. And the letter is often 20, 30, 50 pages. And then you discover pretty easily that if the courthouse checks the regulations, they are almost never exactly executed than in those 20, 30, 50, 100 pages. Always some things are not exactly done right. And then the protest is agreed upon. So we had one person going to the courthouse and he said, we are not executing the nitrogen deposition rules correctly. And the highest court said, after 1 year of study, yeah, at certain points, the Netherlands is not following exactly the rule. And then the decision was countrywide to stop all projects which produce nitrogen in the air. Industry, traffic, they couldn't stop that, agriculture, no building anymore, no constructions. And that were at that particular day, 18,000 projects stopped constructing. And people didn't have work anymore who are in the construction. So that was a big thing, and that changed the whole, then the nitrogen crisis started. Isn't that something? We had the nitrogen crisis. What are more factors which influence the discussion. There is quite some demand for agricultural land. And the dairy and crop farmers occupy most of that land. We have increasing population. We need 1 million more houses in the next years. 1 million out of 18 million people. Of course, sun panel parks are popular. Windmills are built everywhere. Data and distribution centers require huge amounts of land and they built them everywhere. Just last year, Facebook, in the area I live, bought 4 farms, 4 times 50 hectares, 200 hectares to build a data center. Facebook from America. So they built that one big building to deal with the data from you, from us, from everywhere. Only it happened that it is still not built because then it became known that the energy they needed in that building was the same amount that is needed for the whole city of Amsterdam. So then there came discussion from, yeah, but what happens? We don't have enough energy. We built sun parks and windmills, and now one big building, and that's equally to Amsterdam energy. So they stopped the process, and now Facebook has 200 hectares, but no building yet. Under this situation, we had for the first time in 25 years farmer protests. Maria? Completely new to us, and that was, yeah, here is still a picture from my area, sun parks, windmills, very active building those. And yeah, it's needed for the climate discussion, for avoid fossil energy. The next one, Maria. We had this kind of interesting experiences. All the farmers together, all sectors went on the road. 2 scientific institutes and the next one to the government, asking attention for that. This is near our government building. It was completely unique and it's still in fact going on, but at the moment a little bit more quiet because there is some discussion. Next one. Maria. This is, as researchers, where we have to deal with manure. We have some ammonia and also some methane. Although methane is not only manure, actually the majority of methane comes from the cow, from the mouse, from the rumen. I come back to that later. But as researchers, we have to deal with reductions in the emissions, and that's what I now talk about. Next one, please, Maria. One discussion we already had, and that was in the past about manure going to the nitrogen going to the air. And then we more or less did a big thing by, and it was a step, developed on our station, actually on my station, experimental station. We started injecting manure. This is one of the original prototypes, and that helps a lot. Manure injection in the soil to avoid nitrogen emissions. Again, in our soils, it's more or less possible. In Slovenia, you may have a bit more stones and whatever, so it may be more complicated, but this is obligatory in our country. And that helped a lot, but that was in the past. Now we are in the present. Next one, Maria. This is just to start what the work we have to do, also as researchers. This is the map the government presented in 2022, just how agriculture should adapt to reductions. And these are reductions in nitrogen. That can be ammonia or nitrogen oxide. When you look at it, then the red areas are the areas, especially in the center, there we have some nature land. but it is usually close to small nature areas, and there we want to reduce ammonia, nitrogen reduction of 95%. And the other colors are all around, and the lowest reduction percentage is 47%. That is all to keep the nature areas in good shape. For European purposes, at European request, filled in by our country. Next one, Maria. We work already many years, and that are my colleagues, and we are more or less experts in housing, how to deal with manure, as already also Dr. Peyraud told. Try to separate urine and manure, urine phases immediately. That helps to reduce ammonia emissions. So we have devoted a lot of effort to that, and we have a whole system of ammonia-friendly floor systems in our country, a whole row of those floors. I must admit that they are now a little, somewhat in discussion, and that's a pity. They are obligatory for farmers in in most regions, but the discussion is a bit this. When we developed it and tested it, for instance, we found 25% reduction in ammonia. And now, after so many years, other researchers check it in practice, and they do measurements, and so just on field farms. And then the outcome is that they do not find 25 or 30%, but for instance, on average, 5% less. Or sometimes even a bit more or less. And yeah, so what we told is in practice a bit less. And that becomes a huge problem, because if you go to a courthouse, the court believes the documents which are produced in the past about reductions. But when it is a bit less, you are in problems, because they don't believe the truth anymore. So several of those floors are at the moment in the courthouse not admitted anymore, because they are less in practice reducing than we have it on official papers. That's a pity, but it's a lesson for the future. It's just practice, how it goes in a society over the years. Next one, Maria. We worked recently, and also even Slovenia, Maria was in it, also to look at a more friendly housing system. And it is a bedded pack, and it is more animal friendly probably. And it is interesting because you can, it's a little bit, it could be a bit like a biobed in which ammonia and perhaps methane could be catched. But the reality is we are not sure. We need more research in that area. And there is one real disadvantage with emissions or with the nutrient balance. You import wood materials, carbon materials on the farm. So you import additional carbon. And all those materials, straw, wood, it costs money, and it is these days even pretty expensive for some reason. And if you import carbon on the farm, there's also the risk that you emit more carbon. And that's not good for the climate. So there is a problem. It's the same if you import nitrogen on the farm. It's a wonderful fertilizer. It's hugely plus, but your emission will always increase a bit if you import it on the farm. So that's the side effect. Next one, Maria. Then we were enthusiastic about this system. We found out and we established an artificial floor, even with trees, to make it pleasant for the consumer. Big success, but probably more friendly, but we are still checking the emissions. And this floor also has the principle that the urine should immediately go through it. Urine is separated from the feces. Feces stay on the floor, urine goes into it, goes below it. But we are not 100% sure about the advantage in emissions. It's still under investigation. And probably it's a little bit less than we hoped. Next one. And we actually even saw this system going to Slovenia. And that is something. Anyway, very nice barn, same idea. This is in Slovenia. Next one. Maria, now we also work on this. Beautiful, good for this is for sure the best system for animal welfare. But again, you can see it on the left, we look at the emissions. They may be better. It looked good till now, very nice system, good for the consumer. But handling of sand on the farm is not that easy. So there is also that point. And we need to remove the manure from the sand one way or the other. So there is also some concern, especially about what to do with all that sand. And but this is a new topic here. It comes from America, where sand, they call it the golden standard to use, also in boxes. Next one, Maria. Yeah, and then this one, this is on our farm. We are pretty proud about it. Maria, can you let it work?
I will try.
This is our cow toilet. Actually, it's produced by a company, but we tried it out on the farm. And whatever. If it just tick on it, Maria. If it doesn't work, I can just tell you, you see there a little pot behind the animal that is going up and down. And you would see if it works that after a while, this cow starts urinating. And it urinates in the pot. And it works. That's fine. Then you lead the urine in a pipe to a reservoir. And you separate manure and feces. It's really a good system because you separate immediately. You have no ammonia emission then. But the cow is not all day in this feeding box. So we only catch part of the urine. And yeah, in my opinion, we just catch not enough yet. We catch less than half. And 40% or so. So somehow we need to catch more, but it really helps. And we in our country, and we believe that the future is that you produce on animal farms products, manure products, which are very specific. For instance, solid manure, liquid urine, and other products derived from that. So you imitate the factories, and we believe that's the future. Very specific products which you can handle on the farm and put on the fields. Maria, we didn't manage. Next one, please. This is now our new effort. It's almost a hobby at the moment, but we have a vision. Sometimes you have a vision And our vision is a bit, it's not of all of Wageningen University, but of a group, and I'm part of it. Our vision is that we notice with those big reductions, which is asked by the society, and those reductions are for ammonia 50%, for greenhouse gases, it will go the same direction. We realize we can discuss that, and then it can be delayed, it can be perhaps politically you can make it a little bit less, although not in our country. But the truth is that in the future it will not become less, it will become more, those reductions. So how can we deal with that on those farms? And we notice that with all the practices we look at, we really make some progress. Feeding practices, grazing practices, breeding practices, all 10, 20, 25 at the most sometimes. And if you go that route, the farmer has to implement them, and it becomes an accumulation of practices. And then you need to control it. Because if somebody goes to the courthouse, it needs to be proven that you really achieve the reduction which is in the political rules, in the government rules. And that's not easy. How you control feeding, how you control grazing management, how you control all that on the farm. We look now for measurement tools on the farm, such that you can prove it. Or that in the courthouse, people can say, look, it is really happening. And it is not only a story from wherever. But it is complicated, and it is an accumulation of practices. And we were thinking, and take one example. One practice which is now coming, and that is for methane, reduction of methane in the barn. That is feeding the cow a methane blocker. That is an additive that reduces the methane coming from the stomach of the cow. And we researchers have proven that it helps from 15 till 25%, something like that. And that's a big thing. But we must also realize that if you go that route, that you feed your cattle their lifetime with such an additive. So you pay for it. In fact, you change the rumen the working of the rumen. You adapt the animal. So it's quite something. But it helps, and I think we will use it for the lifetime of the animal. But it is still not 50% or so. No. And you need to control it. Well, it can be done by, I think, by the bills from the feeding company who delivers it to you. We do huge efforts in the breeding area to change the cow such that it will produce less methane. But that means you change the inside of the cow. Well, why not? We always are doing and making improvements with animals, but still, it's all an issue. So we were thinking, why not leave the cow as it is and just try to catch ammonia methane from the air? And that's now the route we go. Marie, if you go one back, then you see some farmers in our country, in the pig farming, they catch the gases from the air, but that are closed buildings. So it's a well-known technique. You can take the emissions from the air by filtration. For instance, ammonia, this is actually even a dairy farm who is doing that. You just take the air from the building, it goes in water and an acid, and it takes out, 85–90% of the ammonia if you have all the air going through the system. So that's huge. But you need all the air from the building. It would be better that the building is a little bit closed. And our society and even farm leaders don't like to close that building of dairy cows again, as we had it in the past. So that's not a very popular route. Next one, Maria. Actually, this was also such a farm, and this farmer still had the side walls somewhat open, but not so much. That was such a farm which is taking ammonia by filtration. Cost money, cost energy, but the system in itself is working, we know. Next one. Because we don't like to close or to take the air from the whole building, the development from this year is that we have companies, and this is a particular company who produces the same idea, but they have a machine who filtrates the air from the manure storage. There's where the manure is collected. And it works in the same way. They use acid and the ammonia is taken out, and we believe that there will be a certification for 70% reduction from the barn. So then you have 70% reduction. Oh, that's worldwide, so that looks good. At the moment, we build these kind of equipment on 50 farms in our country, dairy farms to start with. Good reduction, but it costs money. It's not cheap. It's a big investment. It's manure storage, and a little bit about the floor is taken. The air is sucked into these machines. It can be very important for the future. Next one, Maria. As researchers, we actually like most a little bit other systems which are more nature-oriented, more organic, and that are biobeds. Here you see a picture of a farmer in our country on the right and the left, who himself takes the air out of the manure storage and he pushes it in the drainage of the land. Now we have all our land drained, so there are pipes under the grassland. I don't know if you have it, but we have it everywhere. So he pushes the air in the pipes. And then the methane and ammonia and other gases go up and go in the soil. And we hope and we expect that there will be some soil filtering of those. But it is still not proven, I think. We have biobeds, smaller ones, where we really see some progress, and that may be some future. Next one is an example of our, as researchers. Here we put the air from the manure storages under the soil, and we measure how much is going in the soil and how much comes out. And we are pretty hopeful. So Marie, if you goes back, so this farmer on the bottom, he builds a new farm, and that little piece of grassland you see on the right, you see the little holes, and there the air from the little holes in the wall will go in a biobed. So on that side we will have a soil, and the air goes into the soil, and we hope and we expect that at least part of the ammonia and methane will stay in the soil by creating an environment of bacteria, of digestion. And in the research world, we have some hope there. But it's still a route to go, I must admit. Next one, Maria. Next one. And then specifically methane. I was just talking before about methane from the manure and the storages, manure storages. But most methane comes from the cow. And that is really something we cannot yet handle so well. This is in research in Denmark and our country where we have cows and we try to grasp the air from the mouth of the cow that is full of methane. This is in our country. Next one, Maria. This is more a practical application in Denmark. There they have pipes in which they try to catch the air from the top of the noses of the cows. And then if methane is more concentrated, we can catch it. In the present concentrations in the barn, it are such low concentrations that we have problems of catching it, of grasping it. But when it is more concentrated, there are ways to do so. Next one, Maria. Just to conclude a bit the world, again, in the Western Europe, in some countries, I think we are in a big discussion about emissions and biodiversity. Animal welfare will stay. We have many practices to reduce ammonia, but it are often moderate reductions. In some areas you can start with it, in other areas it may not be enough for the near future. Ammonia reduction by filtering air is very promising and it is possible, but it is a costly investment. Where I did not talk about, but that's done pretty much, that is experienced in Denmark quite a bit. You can also add acid to the manure immediately, acidification of manure. Actually, that helps to avoid ammonia emission, the same principle. It also helps when you put it on the land because ammonia stays in. And the manure is still in the acid is in the manure. But what we often do not know, it also prevents the escape of methane if it is very acid. So part of the methane stays in. So that's a nice. Still, we don't like the system so much in our country, acidification, but we should look at it again. And finally, everybody who can help us to find ways to reduce methane by filtering air is very welcome. It's a challenge, and we still think it's the route to go. Combine methane and ammonia, both take it from the air, and we would really solve a lot of discussion about this whole topic. But we are not yet there. Thank you.
Thank you very much, Abele. I'm sure people have questions for you. Mrs. Anna Petek asked, how much do the methane blockers affect the cattle after their rumen is adjusted to them? Does it have a significant effect on their lifespan or welfare?
Maria, you know that we had last year a climate care farming seminar at the European Association for Animal Production. And there were presentations about this, and the American expert, Mr. Alexander Bristow, and some others told us it sure has a positive effect on the reduction, but please let me also look more to the long term. And of course, we don't have yet the experience in the long term. We are not yet so concerned that it would affect the health of the animal, I think. We are not sure, but I don't think so. It's more that we are not so sure that in the long term it will still work. If you feed the cow 5, 6, 7, 8 years, how will it be over 5 years? We do know this methane blocker is a chemical compound. So we expect that will work for a longer time. But we have also additives who work the same, but they are organic. They are more welcome, in fact, organic additives, and they are more friendly. But we do know that those do not work in the long term. Then the animal adapts to it. So the answer is for those chemical additives I talked about, they work, but for the long term, of course, we don't have that experience yet. So that is a point of it. And if it really affects the organs of the animal, I think that is also, we don't expect it so much, otherwise we would not even allow it. But there will come surely research of organs in the future, looking at it. And I think we must admit that with all those things, you always adapt the animal a bit. So the animal should adapt. It's also with breeding, of course. And you probably breed for bigger lungs when you breed for methane reduction.
Yeah.
So you always have some effect in the long run, I guess. Yeah.
Our colleague Stane Glad from Extension Service wrote in the chat, Bill Gates invests in a startup that seeks to control methane emission from cowbirds. The Australian startup Rumen 8 is developing a dietary supplement that inhibits the production of methane using red seaweed, a source of synthetic material.
Yeah.
What do you think about that?
Yeah, there are several organic additives in research. I'm not an expert, to be honestly, but we hear presentations about it. Until now, they are not so we are less certain about them than about that chemical methane blocker, which is offered by some big companies. The results are less clear. So that is, I think, the reality.
Abele, I have one short question from my side. Newspapers and media wrote about 3,000 dairy farmers in the Netherlands, that they will lose land or that they need to stop with farming. How this going on? Is this true or what is behind it? All this?
Maria, in the reduction goals I presented and the approach recently, that has to do with what we call the nitrogen crisis, but it has to do with nitrogen emissions, ammonia. The idea is that to solve it in the short term, the government...
Igor, can you switch off microphone? Sorry.
Oh, sorry.
The goals are not to do it in the long term. They want to do it before 2030. They want to reach the goals of the nitrogen reduction, ammonia reduction. So now the idea is to speed up, and you can speed up by buying out farms, crop farms, but mostly dairy farms, no, animal farms, close to the nature areas. So the idea is to buy 3,000 farms who are immediately close to those areas. And then you can make nitrogen emission free to use for other purposes. I give you one example. We just learned that our airport Schiphol, they don't have a nature certification, but they also produce nitrogen emissions. Not as much as the animal sector, but they produce. Lately, they bought 20 farms, just recently. Agricultural farms can be probably most animal farms, and then they can use that nitrogen produced on that farm that becomes part of Schiphol. So they can use it to let the airport functioning. That is about the practice at the moment. I told you about Facebook, who bought here 4 farms in the lowlands. They can use that nitrogen on those farms to produce nitrogen emissions with their building. So that is the practice. So nitrogen becomes an asset. It is worth money, nitrogen going to the air. So there is a huge effort going on in buying out farmers, and the government indeed likes to buy out 3,000 farmers. That's and they are in the process. But of course, farmers get money. They get good money, and it starts by being a voluntary process.
Okay, thank you very much, Abele, for your presentation. And we would like to continue with the third speaker, Professor Dr. Mizeck Chagunda. I saw that he's with us. Professor Dr. Mizeck Chagunda bo predstavil temo kvantificirane emisije metana pri preživkovalcih z uporabo laserskega detektorja metana. Professor Dr. Mizeck Chagunda, if you permit me, I will make short introduction in Slovenian language, and then I will ask you to make in English also. So, Professor Mizeck Chagunda je profesor in predstojnik oddelka za živinorejo v tropskih in subtropskih regijah na Univerzi v Hohenheimu v Nemčiji. Dr. Mizeck je doktoriral iz reje živali in genetike na Univerzi v Wageningenu v Nemčiji, potem ko je magistriral in diplomiral na Univerzi v Malaviju. Pri tem je delal na različnih raziskovalnih inštitucijah na Univerzi v Malaviju, Univerzi v Wageningenu, v Aarhusu na Danskem in pa na Škotskem razvojnem koledžu, kjer sta se midva tudi spoznala. Medtem ko je profesor Mizeck na Škotskem sodeloval pri več raziskovalnih inovacijah v zvezi s prerejo mleka, je bil tudi v ustanovni skupini in je predaval v skupnem magistrskem programu Univerze v Edinburgu za varnost hrane. Trenutno pa je izredni profesor na šoli za biosistemske vede in bioinženiring na Afriški inštituciji za znanost in tehnologijo Nelsona Mandele v Tanzaniji. Poleg tega pa je predsednik zunanjega svetovalnega odbora za program Supporting Evidence-Based Interventions s sedežem na Univerzi v Edinburgu. Professor Mizeck Chagunda, please can you introduce shortly yourself, and then you can start with presentation.
Thank you very much. And before I even introduce myself, thank you very much for inviting me to be part of this seminar series. I really feel very honored to be part of the lineup to discuss these issues this afternoon. So thank you very much. And that was almost like a crash course for me in Slovenian language. It's amazing how much I understood of what you're saying. So my name is Mizeck Chagunda, originally from Malawi in Southeast Africa, where I studied at the University of Malawi until I got a master's there. So Bachelor of Agriculture and then Master of Animal Science, before moving on to the University of Göttingen in Germany, where I did my PhD in animal breeding and quantitative genetics before going back to Malawi to be lecturer at the University of Malawi, where I was lecturer in animal breeding and genetics. A few years later, I moved on to Denmark, to the University of Aarhus, where I was a project scientist and did my postdoc there with the likes of Nick Friggins and others. And after working at Aarhus, I then moved on to Scotland. I was in SRIC, which is based in Edinburgh, and I was also associated with the University of Edinburgh. From there, I moved on to University of Hohenheim, where I took up the full professorship of animal breeding and husbandry in the tropics and subtropics. The work that I am going to share with you this afternoon is on quantification of methane emissions from ruminants. And this is with specific interest in the use of laser methane detector. I'm really glad that I'm following on from Professor Kuipers, who in his presentation mentioned methane several times, and also even introduced the issue that most of the methane that comes from animals comes from the front and not the back. And this is really good introduction of my work. So what I intend to do is very quickly just give an introduction, and this may link to the previous speakers in terms of why do we really bother talking about methane, more especially enteric methane. And then I'll quickly introduce some of the quantification methods that are there before moving on to this specific laser methane detector. Now, the issues about the laser methane detector that I will try and raise in this presentation are things like, does this gadget or the data that we get from this gadget, do those data agree with the gold standard, which is the metabolic chamber? At the same time, I'll also ask and try to address the question, is the data that we get from the, or are the data that we get from this LMD, the laser methane detector, robust enough as a data source? And at the end of the day, I'll try and also demonstrate the fact that we may, or we may not, we'll see at the end, whether the data from the laser methane detector can actually be used in animal breeding programs. I should already acknowledge that some of the information I will be presenting in this seminar is not from my own work, rather from collaborators that I've worked with, and also from people that have picked up the methodology that we developed and moved on with it, did measurements on their own in their own independent research, and they are reporting those results. So I would like to acknowledge already that I will use some slides which are based on other people's work, just to give this story a complete sense of it. I also want to acknowledge the contribution of several of my PhD students and postdocs that have worked with me over the years. We started this work in 2008, so 2008, when I was still in Scotland. And I would like to acknowledge all the collaborators, technicians, and students that I've worked with over the years. Now, why do we really talk about climate change as animal scientists? I'm pretty sure this has been discussed earlier on, but I just want to emphasize the fact that climate change is not just an environmental issue. Climate change is a human issue, and climate change is a human health issue. When we look around at cyclones happening in different parts of the world, which are very unprecedented, increases in frequencies of those extreme weather conditions, we see that climate change is not just really bothering the environment. It is a human issue, a human survival issue, a human health issue. And that should really make us start thinking seriously that we need to do something as agriculturists and also as animal scientists. On the other hand, enteric methane as such is also something that we should be concerned with, because we know that methane contributes to climate change. And if climate change is, if we agree that it's a human issue, human health and human survival issue, then enteric methane emissions are an issue that we should be concerned about. And this is because it's one of those gases that indeed contributes to climate change as a greenhouse gas, and we know that it's very potent. But also, current reports have indicated that mitigation of methane may actually be one of those quick wins towards lowering the global temperatures. In that case, then, mitigation of enteric methane production from ruminants is an important part of that big story, of that global issue. Earlier on, we had the presentation that also mentioned that methane emissions from animals are coming from the rumen, where there's fermentation happening. I just want to kind of add on that to say, yes, indeed, it's a normal procedure. It's a normal system that happens with ruminants. Without the production of this methane from animals, there wouldn't really be ruminants, because they rely on the use of microbes in the rumen to digest some of the food or feed or materials that a normal or a simple stomach system does not digest. So human beings and other monogastrics cannot really work on the fibers that the rumen microbes do work on to make feed for the animals. When we look at it from the farm level, greenhouse gases, and methane in particular, is not just a greenhouse gas issue that affects climate change, but we also know that it's directly related to feed efficiency. In which case, too much production of enteric methane from animals represent an inefficiency in the feed utilization. So at the end of it, too much enteric methane production is actually not good for the farmer's pocket. It's not good for profit. At the same time, it's not also good for productivity of those animals. As indicated in this graph here, which is indicating too much or the high levels of methane per kilogram live weight are very much an indication of little live weight gain in this population of animals. And the story is the same with milk, the same is the story with the other products from ruminants. High methane production is not good for the farmer's profit. There's been some recent developments. So earlier on in the discussion, there was the issue of introduction of the additives, feed additives. That has really been some good development. And indeed, from the picture, you can actually see here on the right, this I got from the Global Research Alliance from New Zealand. Indeed, there are all those organic feed additives and also inorganic feed additives that are reducing methane. But at the same time, we've also seen that there is quite a lot of progress being made in the animal genetics side of things, in the breeding side of things. Just last week, CIMEX introduced a new methane index in its genomics work. This is really good news that people are now dealing with this issue of enteric methane production from both the animal nutrition point of view and also the animal genetics point of view. And we know that animal genetics, animal breeding may be slow, maybe a little at a time, but it's very additive and also it is permanent. In which case, this may actually be one of the ways in which we could deal with this problem coming from livestock. And of course, if we can, if we are able to capture the methane from the farms, from the barns, like it was demonstrated earlier on, and use that for energy, that may even be another good innovation that may deal with this problem. But for now, that solution hasn't really worked out on practical level. But these interventions in animal nutrition, interventions in genetic improvement are actually becoming a practical way in which methane emissions would be reduced. However, although this is good news, even earlier on in the presentations, it was indicated that we need to measure, we need to know where we are, and we need to know where we are going. We need to know how much we've reduced. So even with the genomics, and people like Mike Coffey of SRIC are very popular for saying the phenotype is king, even in the era of genomics. And that is true, because even with these interventions, the gap that's there is the data gap, the measurement. This is not only in the intensive production systems of Europe, where we don't really have a lot of data from commercial farms or production farms, but also in the more extensive production systems of Sub-Saharan Africa, for example, of Southeast Asia, and also of South America. So the extensive systems of the tropics and subtropics, we don't really have a lot of measurements from those animals. As well as even here in Europe in the intensive systems, but in the production systems, we don't also have a lot of data. So the gap that's there is this data gap. We need to measure things. We need to have the phenotypes in order to have those interventions in nutrition and also those interventions in genetics, genomics. What are the available methods that are there in terms of measuring enteric methane from ruminants? So this scheme here demonstrates what's there at the meantime. We have direct measurements and we also have indirect measurements. I will not go through all of them, but suffice to say that some of the direct measurements are long-term measurements, and you can have those at individual cow. And as an animal breeder, an animal geneticist, I like that, because if you have individual animal data, that's where you can start to really select for those animals that are better for whatever trait you're looking for. But also there are these methods that you can use at group level. These methods are good when you want to think about it from a management point of view. The short-term measurements, these are measurements that are not really getting your methane measurements for a long time. They are short-term, they are a few minutes or a few hours, but they also give you a good indication of what those animals are doing. Most of the indirect methods are what are called proxies. So the proxies that are linked to methane, they may not be measuring methane themselves, but whatever they are measuring is actually very directly correlated to methane. I would want to specifically mention one there, the mid-infrared spectroscopy in milk. I mentioned that because the method that I told you earlier on about the CIMEX work is actually using or applying the correlation between that and methane emissions, which is in the work that they have used, and they are citing round about 0.85, which is 85% correlation. Other people have also used fatty acid composition in milk. Now, why is this milk part interesting? It is interesting because if you're dealing with dairy cattle, milk is readily available at every milking. And that's a good platform for measuring things that are not invasive to the animal. Is it possible? Is it plausible and feasible to every animal? No, because animals like heifers, they are not producing milk. Beef cattle are not producing milk in most cases, and bulls and male animals are not producing milk. So other proxies may become much better in those animals that are not producing milk. Talking about the gold standard. The gold standard for methane emission has been the metabolic chamber. This particular one here is, there are 6 chambers that are available at SRUC in Scotland. As we can already see, this is heavy duty equipment. It's not available in every research institution. It's not available in every university. It's gold standard, it's good, but expensive and not available everywhere, so not accessible. At the same time, it also requires a lot of technical expertise. One cannot just wake up in the morning and say, I'm going to operate a metabolic chamber. You need well-trained technicians to do that, and they are not available everywhere. The other method that I want to highlight in grazing animals is the SF6 method. Now, this method has been used quite a lot, but we can see that one of the disadvantages already, which we can visually see in this picture, is that the behavior of the animal will be altered because it is something that an animal is not used to carrying every day, to have a backpack. So in that sense, it is the behavior of that animal may actually be distorted a bit. But at the same time, it's using a gas. SF6 itself is a greenhouse gas, which is even more potent than methane. In that case, we are sending a much stronger thief to catch a weaker thief. Is that the way we want to do it? I don't know, but it's another method that can be used. There is another method that is commonly used, and I would like to highlight that this method is the method that, again, talking about the CIMEX work, the animal breeding work that they have highlighted that they used. It's called the green feed. It's a hood that is there, and when animals go and feed, it's collecting a sample of the breath and measuring the concentration of methane, then convert it into the amounts of methane. It works, it's robust, but again, if you're talking about grazing animals and talking about extensive systems, like we saw in some of those pictures in the tropics, subtropics, this may not actually be very practical. This is where people have been thinking of, can we use some non-invasive measurements using breath as the platform? And this is where some of our work comes in. The work I talked about starting in 2008 came in with this thinking. Can we come up with some measurement, some technique that's not invasive, easy to use, portable, and using breath as a platform? After that work, we know that there are also other sniffer kind of methodologies that have been developed. But for now, I would like to talk about this laser methane detector. In which case, if we can measure in the breath of the animal, which we already were told that the breath that animals are producing is full of methane. Actually, people estimate that 90 to 95% of the enteric methane produced by ruminants is from the front. So if we can have a good picture of what's happening in the breath, in the exhausted breath, we may actually have a good picture of what's happening with that whole animal. So providing a cow side method that may actually provide some of that evidence of how much these animals are producing and then guide our interventions. And in this picture, the motivation is again the fact that we are using a platform that's not invasive, but at the same time having a lot of confidence that we are talking about more than 90% of the stuff that we are looking for. Now, this work started with the laser methane detector when I was in Scotland at SRC. We did not invent the LMD. We did not design and come up with the laser methane detector. It was already there. It's a gadget that was developed by the Tokyo Gas Company in Japan. They did not make it for livestock. What they made it for is they made it for environmental engineering. So measuring methane in old mines, measuring methane in gas pipes, leaking gas pipes, measuring methane in landfills, and those places that produce methane, which is from digestion of whatever stuff. In which case, when we looked at the spec of that methane, we actually realized that the spec is almost exact as enteric methane, because the biology of that production is exactly the same. In which case, that's the reason we pioneered starting to test, to design experiments and test the protocols in the use of this gadget. The initial gadget that you see in this picture, the version that was there was actually quite big, although still portable, but much bigger and a lot more noticeable. Later on, they have actually reduced the size of this gadget. But before we come to the reduced version, what we did earlier on was really to look at the feasibility. Is it feasible to measure in animals? And from all those pictures, you can actually see that what we were trying to do is measure methane without disturbing the animals at all. So all those animals are just doing whatever dairy cows like doing, looking outside or eating and doing measurements. And from that, we moved on, asking one question at a time. Fortunately, most of that work is now published. But it was really asking one question at a time, or maybe two questions, in terms of, can we use this gadget? How robust is it? And can it give us measurements that are making biological sense in grazing environment, in housing environment, and all that kind of stuff? The newer version is actually much smaller. So the one you see in the bottom picture, in the bottom picture is actually the newer version that transmits data directly to a tablet. So this arrangement is really just putting the tablet very close to the gadget, and with an app, that tablet is showing exactly the same dashboard that the LMD is showing. The interesting thing is that the technology used in this gadget is actually well-proven technology, is infrared absorption, and it uses a secondary semiconductor, which then is this thing of you send out a laser beam at a known frequency, and if it hits methane, it actually comes back to tell you the concentration of that methane in the path where that wave has been sent to. So it's well-proven technology, very robust, uses laser, which is not distracted very easily. So the measurements really, when you start measuring from specific known places, it actually gives you what you're looking for. But still more, as animal scientists, we asked other questions, and I'll come back to that. This graph here is just to show you that you can actually measure methane at two different well-known bandwidth. The first one is the 3.3 and the second one is 7.6. But you can also have, so those are the strong absorptions, but you have two other bandwidths at which you can measure methane, 1.64 and 1.70, which in this case, in this graph is represented by the red bars. The interesting thing though is this LMD is tuned for the two bandwidth, the 1.64 and 1.76, the so-called 2v3 band. The interesting thing with that is that when you measure, when you create devices at that bandwidth, it's actually cost effective. And also it can be applied in a portable system. And that's really what this LMD is relying on. So the newer version, it's now being used quite a lot in different groups. This picture, we can actually see that we have the new version and not a Holstein Friesian cow this time, but another breed. The question that we start asking as animal scientists though is that, because like I mentioned, this gadget was not made for livestock. How do the data look like when you measure from animals? So what you get is actually a spread, the spreadsheet that's on the left. It gives you all the measurements and the data points, so the date stamp, and also it gives you the intensity of measurement. So how well the gadget is working before it gives you what it has measured. And as if you are somebody who is interested in the engineering, you can actually pick up the intensity measurements and analyze how well this gadget is working. But as an animal scientist, I'm more interested in the measured value because that's the methane that I'm getting, and also the timestamp to know exactly when I have been measuring. The thing though is that it doesn't give you what kind of animal or the ID of the animal. You have to write down on a piece of paper or on another gadget to time link which animal you've been measuring from and the behavior of the animal and all those things. But then when you actually plot those data, you actually start getting these kind of profiles. So profiles that are giving you the amount of the concentration of methane that's coming in, because this gadget gives you parts per million meter as a concentration. The meter is how thick is the plume, and the parts per million, what's the concentration of methane in that plume. And you can actually see that it's really profiles that are really showing the breath cycles in that animal. And we know from previous work and other people's work that animal dairy cattle, for example, are eructating or burping almost every minute. And we can actually see those profiles, in which case then we can start segregating breath from eructations and use the eructation data, because that's methane concentration, or the concentration of methane coming straight from the rumen, as opposed to the breath, which is methane coming from the lungs, because we know CH4 methane is a small molecule that easily can go into the lungs as well through the blood system. So we leave out the breath, we extract out the eructations, and that's what we use to determine how much concentration we are getting from these animals. And quite a lot of groups are now working on how then can we convert that concentration into grams per day or grams per milk, per kilogram of milk, and all that kind of stuff. The question though is, are these data robust enough? There's been a lot of questions on what happens when you change the distance from where you are standing towards the animal? Because in the first paper, we came up with 3 meters. And then we actually adjusted that to say the best is 1 meter. But the 1 meter was basically because we knew the plume is less than 1 meter in most of the time, or just about 1 meter, in which case the conversion rate will be just 1. But the question has been, what if I stand 2 meters or 3 meters from the animal? Or does the next animal standing or lying close to this animal affect the concentrations? And also, if I'm standing at a different angle, straight 90 degrees to the animal, or 180 degrees, or 60 degrees, or 45 degrees, does that affect the measurement? This work has been done by colleagues from France, from IDEL in France. So Bolle et al. Produced a paper last year indicating that actually all these issues are not affecting the concentration of methane. What affects the concentration of methane measured by the LMD is how long you measure. So don't just go there and measure for 10 seconds. Currently, the recommendation is 4 minutes, and it's because we are saying at least you can capture 3 eructations. But this study is saying anything less than 4 minutes is indeed affecting the concentrations, but anything more than 4, you're just gaining the confidence, but it's not really adding anything. So around about 4 or 5 minutes is still a good recommendation. The other question has been, do we have an effect when we feed different, so when the animals are feeding different things? Can the LMD show the difference in feeding types? This study was done by colleagues at SRIC, and that was published way after I left. They had cows being fed 100% grass and 50% grass, measuring with the LMD. And we can actually see that there was indeed a difference in the 2 groups. Whatever was happening in week 5 and week 9, I don't know, but the fact of the matter is you can actually see the distinguished profiles of the 2 feeding groups. The other question has been that if you look at the individual feeding behavior of the animal, is this gadget picking that? And indeed it is. So the feeding rate, how much the animal is chewing, you can actually see that there is a difference there in terms of discriminating the animals that are feeding slowly and the animals that are feeding more. So indeed, this gadget is sensitive enough to pick behavior differences, in which case we need to account for those behavioral differences in any other model that we are using to analyze those data. Paul Hargreaves looked at animals that were healthy and animals that were sick. The sick ones were treated by antibiotics. Does this gadget measure methane in these animals and show the difference? And yes, it does. There was two different profiles for health animals, the solid line, and the animals that were sick. And we know that from biology, sickness indeed affects the methane emissions. And obviously, we also know that when animals are on antibiotics, that affects even the rumen microbes. So indeed, this gadget would show us that it would pick those differences. And that's good news because it shows that it's giving us biologically sensible data. But giving us biological sensible data is one thing. Are these data agreeing with the gold standard, the chamber? This work was done earlier on, looking at the exhaust methane from a chamber and measuring exactly with the laser gun or the LMD on where the chamber was getting data. And we can actually see, so the red is the LMD and the green is the chamber. We can actually see that the profiles in most of these animals, so every panel here is an individual animal. The measurements were from 7 o'clock in the morning until 4 o'clock in the afternoon, continuous. And we can actually see that the profile the profiles were pretty similar. Of course, there were some animals that the LMD was measuring higher than the chamber, but pretty much in the same kind of profile. The animals in the chamber were also exhibiting different behaviors. And we can actually see that from the dotted points, these are the measurements in the chamber, which were coming every 4 minutes. And the continuous line is the LMD, which in this case is the secondary y-axis. You can actually see that the profiles are showing the same behavior pattern. So when animals were ruminating, feeding, resting, feeding, ruminating, you could actually see the pattern almost mimicking each other. In which case, there was quite good agreement between the chamber and the LMD. Looking at other people's work who have actually also looked at this kind of same question, we can see that the lowest agreement that people got was 0.47, so in terms of correlation, but the highest correlation was 0.86. And this was the 0.86 was actually work done in Germany at the University of Halle with Professor Suave and others. So we can actually see that there's quite a good agreement between the LMD and the chamber, both with dairy cattle. So the graph at the bottom is showing dairy cattle and sheep, and the other graphs are dairy cattle as well. And we can actually see that the correlations are pretty similar. This work was done with an experimental equation of converting the concentration to grams per day. And again, it actually showed that when you convert that to grams per day of the chamber and the concentrations of methane from the LMD, you got quite a good correlation as well, in which case you can start thinking of indeed developing equations that are converting the concentration that you get from the LMD to grams per day to volumes of methane. This work was done by others looking at LMD and the green feed, which I showed you earlier on, and just looking at the patterns. You can actually see that the patterns are almost the same kind of thing, but actually the top panel is the green feed, the bottom panel is the LMD. So in which case, this proxy is giving us quite some interesting data that are linked to the well-known methods. How do we then extract the individual data? Earlier on, I showed you the profiles, and we could see that there are lactations and breath. Colleagues from Scotland also worked on this using some robust statistics to start with the distribution density. And indeed, when you combine all the data, you see that the distribution looks skewed. So you have a long tail to the left. But actually, this group utilized some statistics that picks up the different subtle distributions. And you can actually see that in there are two distinct distributions. The blue distribution, the lower one, is the breath distribution, whilst the green distribution, the higher one, is the eructations, and individually they are both normal distributions. But when you combine everything, then you get this skewed distribution, in which case this confirms our initial assessment to say we should only be extracting data from the eructations, because then you end up just extracting the green distribution and use that. And this is because there's been quite a lot of kind of discussion on, if you plot everything, you start seeing these mini peaks. Are they useful? Yeah, these mini peaks are actually just part of the normal biological variation that comes with any biological measurement. The important thing is to look at it from the respiration versus eructation point of view. This work here is done by his work that I got this slide from Professor Schwabe's work. And what they were looking at is which exact measurement is or trait of this laser methane detector would give us good correlation to the chamber. And also what kind of feed would give us this correlation. So they looked at maize silage, and grass silage, the third column. And one of the things they actually showed is that when you start looking at concentration of methane per kilogram of milk, that is a much more robust phenotype than other phenotypes. So maybe we should actually start thinking not only about kilograms or grams of methane per day, but rather grams of methane per milk produced when it's dairy cattle, and maybe per body weight when it comes to beef cattle. Lastly, I want to ask this question: can the LMD data be used for animal breeding? One of the parameters we use in animal breeding very often is heritability, to show us whether these measurements or this trait is heritable and hence can be used in breeding or not. Again, this work is a slide from Professor Schwabe's group and shows that when they used the single measurements versus using the mean of everything, you got different heritability values. But interestingly, when you start really looking at different phenotypes, it's those phenotypes that are now giving you the confidence to say, indeed, although the heritability is changing, we can still do something with it. So the highest heritability they got in this work is 18%, and the lowest was 0.5. But to put that into context, this is a literature review of several papers that have showed heritability values of methane from breath. So not only the LMD, but also other breath techniques. Just picking the sniffer, for example, this is work done in Denmark at Aarhus. It shows a heritability of 21%. From our own work earlier on in 2015 with one of our postdocs, we had a very small data set. We got a heritability of 0.5. So the work done by Pickering et al, heritability of 0.5. But moving on, the Professor Schwabe's group have gotten a lot of measurements and from different farmers. They've now shown a heritability of 0.28, 28%, which is pretty much in the same range as the other methods. So if you see the sniffer, if you see the green feed, you actually start seeing the heritabilities that are in the 20-something%, which is very comparable to the work that Mulbach et al, working with Professor Schwabe, also found. In which case, this is now giving us a lot of confidence that indeed you can use measurements from the LMD in a breeding program to start really showing that we can do interventions which are much more sustainable. Very quickly, I just want to show you that quite a lot of what I've just talked about is in dairy cattle, but other people have also taken the LMD to other species. Is it making sense? Or other breeds of animals. So this is in the tropics. This work was done in Malawi and from using Malawi zebu, and they also found interesting results that are very comparable to other zebu cattle when they are measured using other methods. There's been work done in buffaloes, in Mediterranean buffaloes recently, and we can actually also see that although these are not heritability values, but the measurements in the water buffaloes are showing similar measurements that have been reported in water buffaloes using other methods. That's exactly the same kind of thing with the water buffalo. The interesting thing though is that in the other species, we can see that the profile is different. So the eructations are not every minute. They are actually a lot more staggered than in dairy cows, which again agrees with the biology of these different species. There's been work done in goats, so small ruminants, and we can see from this graph, which is work done by Rosler et al. In 2018, that also even shows individual variation of goats using the LMD. So where have we been? We've looked at why we should care as animal scientists in terms of climate change and methane. We've also tried to answer to look at the fact that there are a lot of other methods that are used. And then we zeroed into the LMD, the Laser Methane Detector, and does it have a role to play? And I hope that in the past so many minutes, I've indicated to you that this gadget, although it was not made for livestock, it has a role to play in helping us mitigate methane emissions from livestock, because the data so far have shown that they are robust and biologically sensitive. And also we can start thinking of utilizing these data in different interventions, including animal breeding. With that, I would like to thank you very much for giving me this time to share our work in terms of the LMD and also the work of others in this theme of measuring methane using the laser methane detector. I thank you.
Thank you very much, Professor Mizeck Chagunda. I'm very happy that you share these results and experiences with us. I cannot see questions in the chat, but I have a question for you, Mizeck.
Yeah, that's all right.
I follow your presentation already on other meetings, but also today. And I have impression that in fact we need to repeat these measurements. It's not enough one measurement, but my question is how many measurements per cow we need to make to use for the breeding purpose? And
That's a good question.
How often?
That's a good question. So I would answer it in two parts. The first part is, yes, we need repeated measurements, regardless of how often we measure, we need repeated measurements, because even those 4 minutes, you might have found that animal in a bad mood, or even the physiology of that animal. So we need repeated measurements from every animal. Yeah. Now, how often? We haven't really established how often you need this for animal breeding, but I would actually already say, let's start from what we know. So milk recording, for example. For animal breeding purposes, milk recording, we usually have 5 records per lactation as a minimum. I would actually say let's use that kind of standard that already is established. I know that in robotic milking, we get a lot more records per animal, but in the conventional milking parlor, in terms of milk recording, we get a minimum of 5. I would say if we could follow that kind of procedure, we may not be far away from the truth. And it would also give us a good correlation between, so if we are doing grams of methane per milk yield, we are then using the milk recorded milk as our denominator. And I think that would be a good phenotype other than using a completely different protocol.
So if I understand you, then would be good to make these measurements on the same day and then milk recording and connect this data.
Yes, that's what I would do. And that would be a beautiful way of connecting different data sources, because we know that during the milk recording, they are also doing fat and protein. And that's where also the mere data is coming from. So it could really be a good day when we get more than 3 different phenotypes, which we can then correlate much easier.
Mm-hmm. But 5 or 4 minutes per cow is very time consuming. So in fact, we have limited time during the day.
Yes, that's right. That's right. So I would actually say 1 LMD may not be enough if we really want to do serious work for animal breeding. A few of them may be good. The good thing, or the good news, is that work done by Sog et al. Has shown that even when you use different gadgets, the correlation is very strong. So I would actually say that, yeah, if you have enough funds to get, say, 4 or even 5, it's much better. And then you can actually deploy 5 people to the same farm.
Uh-huh. Yeah.
And we also showed in some of our work that when the person measuring is well trained, the difference is not very much.
Mm-hmm.
Yeah.
But I understood that you need 2 empty spaces between 2 cows.
Not necessarily, but that's what we use to test.
Okay.
We tried to test using 2 empty spaces and 1 empty space. Actually, there was no significant difference.
Mm-hmm.
So provided you're targeting the animal that you want to measure from, the difference is really minimal. And it's because from a design point of view, remember, laser beams, when they are made stronger, they can even cut things. So the laser beam is not really distracted that much. And the gadget is made in such a way that there is a threshold concentration that once the laser beam hits that threshold, that's when it starts measuring. So when the concentration from the breath of one animal is high enough, that's when it measures. So the neighboring cow's breath, if it diffuses into this other plume, it's not really giving that threshold concentration.
I don't know if other colleagues have some questions. If not, then I would like to say thank you very much.
I thank you very much as well.
And we will come back to you, I'm sure.
That's all right.
Yeah.
I'll be happy to collaborate with you and help in whatever capacity that you would want me to do, even if it just means explaining things.
Yes. Thanks. Thank you very much.
Thank you very much, and thank you for having me today.